yesterday when I did this lesson with the previous block, previous session, I didn't give them this. I wrote everything down on the board, and then we did the class activities and all that. But I thought about it, and I thought, well, you know, on the board, and then you are doing on your paper, and some people have line paper, some people have graph papers. It's just a little too difficult. So I made this one this morning, and I thought that we can go over this. This basically is the lesson and the lecture, and it's your notes. Okay, so there are 10 problems, and each problem has a function and a graph, and I want you to graph this function on this, plot this function on this little grid here. Use XY table. Okay, use XY. So if you have, you should have a computer calculator to give you the values as you plug in numbers, but plot this over here. Now, as we go from problem to problem to problem to problem, this is very important. It is not just about you be able to solve and graph one problem, but I want you to begin to see patterns emerge and how those patterns associate with the way that those functions look like, how that look like. Does that make sense? Okay, so I'm going to give you the first page first. Once we go through 5 problems, I'll give you the second page. Okay, quickly go over number 1 to get you started. Number 1 says this, right? You have f of x is equal to 1 over x, and we have x and y table. And then I have -3 here. If I put -3 into x, I get 1 over -3, which is -1/3, right? And if I put 2 here, or you can say this is about -0.33 ... right? -2 is 1 over -2, which is -1/2, which is -0.5, right? So that's pretty easy. -1 over here becomes 1 over -1, which is -1. Put 0 in here, I got 1 over 0, which is equal to undefined, right? In fact, I'm going to use red pen. This is a really important point. Be careful, because I went around and I still see people putting 0 there. But this is not 0. This is not equal to 0. Okay, it's not equal to 0. Never get confused about that. 0 cannot be in the negative. 0 cannot be in the denominator. Okay, and then 1. You put 1 here, you get 1 over 1, which is 1. You put 2 here, 1 over 2 equal to 0.5. You put 3 here, you get 1 over 3, which is 0.333 ... Right? And then on the graph, you can start out with -3, 1, 2, 3, -3, and then this is -0.33, so it's about a third of it, right? So a third of the 1 unit, so it's roughly around here, or maybe a little closer over here. -2, I get -0.5, so right here. -1, I get -1 over here. So I have something like this. Okay. And then 0 is undefined, so I can't really plot undefined, so I'll leave it alone for now. I'll see what I can do later. And then 1 over here, 1 and 1. So I have a point right here. 2 here, I have a 1/2, and then 3 here, I have 0.3. So it's kind of like this. Now, if I extrapolate that this is, you know, if I put values that's less than 1, this thing is going to get higher and higher, bigger and bigger. In fact, it's going to get closer and closer to the x-axis, but never touches x-axis. Because if it's not y-axis, if it touches y-axis, x equal to 0, well, x equal to 0 is undefined. It doesn't have a real value. Does that make sense? And then over here on this same way, it's going to go super drastically low without ever touching the x-axis. Without ever y-axis. I'm sorry, I keep saying x-axis. Y-axis. And then the same way that if the value gets bigger and bigger, the number is going to get smaller and smaller. So if you look at the original function, right? If the denominator is getting bigger and bigger, the whole thing gets smaller and smaller, right? Because, like, for example, just take example of 10, right? X is 10 is 1/10. But if x gets bigger, become 100, this becomes 1 over 100. which is even smaller. If x is equal to 1 millionth, this is 1 over 1 million, which is even tinier, right? So it gets smaller and smaller. That's why this thing is going to get closer and closer to 0. But would it ever get 0?
No.
No, it would never get 0, because this thing, imagine this thing, is never going to become 0, right? Because there's no value you can put into x to ever make this 0. Right? Impossible. You can put all sorts of real value in here. It's 1 over some real values. So it never becomes 0. And if you put 0 in here, it becomes undefined. So you completely skip the value 0 as the final answer. So you're never going to get 0. So in this case, what you're seeing is a graph looking like this. And you say, okay, so this thing, there's an invisible barrier for this graph to ever cross. This is an invisible barrier, and we call this the horizontal asymptote. Right? And what's the equation for this horizontal asymptote? Y equal to 0. We also get a vertical asymptote, right? Because there's an invisible barrier over here, and this is called a vertical asymptote. And this is x equal to 0. Okay, so this is the base graph. Now, interesting thing will begin to emerge as we go to the next problem. So go to the second one and plot the second one and tell me what happened.
The asymptote line shifted 3 units to the
Yeah, good. Go ahead and plot it. I want you to plot it and actually show it. Number 2, we got what's it? G of x. G of x is equal to -1 over x. And if we do that using xy table, we end up with -3. We end up with positive 1/3, right? And then -2, we got positive 1/2. -1, we got positive 1. 0 is still undefined. And then 1 gives you -1, 2 gives you -1/2, 3 gives you -1/3. So I will plot I'll use a different color. I'll use the purple color. And purple color here, I have -3 gives you positive 1/3 right here. -2 gives you 1/2. And -1 gives you 1. So it goes like this. So I can already see that, and then 0 is still undefined, so the invisible barrier is still there. So I end up with a graph like this, and then I'll do exactly the same thing on this side. Okay, so for number 2, this is what happened here, number 2. Number 2, the function relative to the first function, what's the difference between the two functions? Yeah. So it's a negative, right? That negative really reverses the positionality of this basic graph structure. Does that make sense? It's switched over. So you want to make sure that you identify that negative and realize that negative is going to give you a curve on this side and a curve on that side versus the other way around. Okay? So now go ahead and do number 3. Okay, let's take a look at number 3. So number 3, we notice that number 3 relative to number 1 is that this function has a +3 in the denominator sitting together with the x. Now we could use a similar set of numbers as before. We can try that, -3, -2. Let's take a look at this. If I put -3 in here, I end up with 1 over negative 3 plus 3, which is 1 over 0, which is already undefined. So somehow I have a suspicion that our asymptote, like especially the vertical asymptote, has shifted to negative 3. Shifted to negative 3. So I suspect that whatever the graph that I have now is move over to negative 3. Now, if it's move over, then that means I probably need to kind of verify a little bit on the negative 4 side and on the negative 5, maybe negative 6, to see if the pattern persists. If the pattern doesn't persist, then I may be into something else. But if it persists, then that will give me a pretty strong clue that the whole thing has shifted. That make sense? So I can try that. So I follow that in back of my mind for just for a few moments, and then I'll do that. But I'll go ahead and keep going with the negative 2. If I do negative 2, I have negative 1 over negative 2 plus 3, which is 1/2. Oh, I'm sorry. 1 over 1, which is 1. All right. And then we got negative 1. We got negative 1. We got 1 over negative 1 plus 3, which is 1 over 2, which is 0.5. All right. And then negative 2. And then if I put 0, I end up with 1 over 0 plus 3, which is 1/3, which is 0.33, dot, dot, dot. I notice a pattern. This is getting smaller and smaller. So that means I don't really need to go further, right? I don't really need to go further. So what I probably should do is before negative 3. So I'll try negative 4. I'll try negative 4. So 1 over negative 4 plus 3 gives you 1 over negative 1, which is negative 1. Okay, what about negative 5? 1 over negative 5 plus 3 gives me 1 over negative 2, which is negative 0.5. Negative 6, 1 over negative 6 plus 3, which is 1 over negative 3, which is negative 0.33, dot, dot, dot. Okay, so I'm ready to graph this. All right, so 0, I get 0.3 right here, and negative 1, I get 0.5, and negative 2, I get positive 1, and negative 3, I get non-defined, so I suspect that I will get a asymptote. So this is undefined, so I will have an asymptote. And so this look like this, right? This probably look like this already. And then over here on this side, negative 4 gives me negative 1, and negative 5 gives me negative 0.5. So, and I don't even need to go to negative 6 because it's probably coming out of the grid. So it's probably going to look like this. And then I will have a horizontal asymptote right here. So I have a horizontal asymptote at y equal to 0. I keep switching them. Y equal to 0, and vertical asymptote at x equal to negative 3. So this is my h of x. Yeah. Yeah. Okay. So now go to number 4. Go to number 4. Number 4 is I of x. is equal to 1 over x plus 2. Okay. Well, this is interesting because I know 1 over x because we just did it number 1. But this 1 over x first, then plus 2, plus 2, right? And this is plus 3 in the denominator. So it's a little different. So the question is, what does it look like? Again, use our xy table. Now, we're building this thing based on xy table. Later on, the idea is we're going to get the training wheels off. This is the training wheels. We're going to pull off the training wheels, and then we're going to look at the complex equations and be able to quickly understand what it is. So over here, okay, let's do -3. -3 is equal to 1 over -3 plus 2, which is -0.33 plus 2, right? Which is roughly around negative 1.67, right? Yeah.
Why is the 1 negative?
Oh, no, I'm sorry. It's not positive. Positive. All right, -2. 1 over -2 plus 2 will be -0.5 plus 2 will be 1.5. Yep. -1 will give you 1 over -1 plus 2, which is -1 plus 2, which is 1. And then 0 we get undefined plus 2, which is just undefined. It's undefined. If it's already in an undefined round, everything's undefined.
Maybe the 2 can get bounded.
Huh?
Maybe the 2 can get bounded.
Good luck. Right. Now, and then 1, you got 1 over 1 plus 2, which is 3. And then 2, you got 1/2 plus 2, which is 2.5. 3 is 1/3 plus 2 is equal to 2.33, Okay, so I'm going to plot this. I'm going to use the red pen to plot on the same graph, okay? -3 and 1.67. So -3, 1.67 is probably around here. -2, 1.5 is probably around here. -1, 1 is right here. And then 0 is undefined, so we will have a vertical asymptote this way. Or I should just stick with the purple. Vertical asymptote this way. This is a vertical asymptote for I, not for H, okay? So it seems like I have a graph look like this. Okay, move it onto this side. I have 1 is at 1, 2, 3. 1 and 3. 2 at 2.5, right here. 3 at 2.33 right here. So it seems like it's going to go like this. Now, if I look at this carefully, the vertical asymptote is pretty obvious, right? The vertical asymptote stays in the middle. Seems like there's a horizontal asymptote, and it got shifted. What's your best guess where it has shifted to? Right before, the horizontal asymptote for this one is at y equal to 0, right? But this time has shifted somewhere. Where did it go? Where do you think the graph cannot cross in terms of up and down value? Huh?
Y equals 2.
2. Seems like 2 is the value that you cannot cross. So here for this one, the the horizontal asymptote is at y equal to 2 for I of x, So what about this function that make it move, make the horizontal asymptote move 2 units? Pretty obvious, huh? That's it. Plus 2. This plus 2 right here. This plus 2 moves the asymptote up by 2 units. Right? Versus this plus 3 moves the asymptote to the left by 3 units. Makes sense, right? If you go back to number 3, it makes sense, right? The reason why asymptote is at -3 is because -3 is the only number that will make this undefined. The +3 requires a -3 to make this 0. Right? That's why the +3 needs a negative value, which is moving to the left. Whereas this one, this +2, doesn't change the signage, right? So it's a plus, then it's going up. If this would be minus, it will go down. Okay? Good. So, number 5. Take a look at number 5. Okay. Number 5.
Are you trying to go to
J of x is equal to 1 over x plus 3. Okay, look at over here. Look at over here now. So we know that this is a reciprocal function. Make sure you remember the term, right? This is a reciprocal function. Reciprocal means reciprocal, right? Move up and down. So reciprocal, this has to do with x going to the bottom. That's why we call it reciprocal function. So x is in the denominator. And now we look at this and we say, okay, now reciprocal function typically look like this, right? With a horizontal asymptote, vertical asymptotes. We know that this is going to move the asymptotes, right? Moves the asymptotes. Which direction? Up. By how many units? 2 units. What about this one? This will move what? Which direction?
Left.
Move left by 3 units. So you can quickly sketch this by identifying the asymptote, right? So you can say, okay, 1, 2, there's a horizontal asymptote. At y equal to 2. And vertical asymptote will be going to the left, which is 1, 2, 3 to the -3. And you have a vertical asymptote this way. And y is equal to -3. And then largely, this is just going to be like this. Yeah. Make sure it's nice curvy, not like that.
Okay, but
It still requires some precision. It still has to have some precision. Precision.
why is this turning into off?
We need precision.
I think even I'm not gonna fail topic 4. Fail topic 4. No, I hate it. When I get caught in the general, I do the not mess up test. I end up messing up. Yeah.
Yeah,
I don't
So it goes down 3 and to the right 2? Yes.
Okay, so here you go. Number six right here. Check your answers. All right, this -3 right here. Moves the horizontal asymptote down by 3 units, right? So down 3 units. This -2 moves it to the right by 2 units. So you draw the 2 asymptotes, and then you have the basic shape. Now this one, basic shape, is still 1 unit, 1 unit. The one that's leading to this point, right, is literally 1 unit, 1 unit, right? Does that make sense? It's the same shape because of the 1 on the top.
Instead of being in these two, it's now in these two.
Okay, number 7, right? Let's do number 7.
It just doesn't work. So now they switch.
I'm going to use a green to do 7. 7 is L of x is equal to, this one you got to watch for this one. There's a -1 up here over x minus 2 and then -3. Now it's exactly the same thing. Now see, look at this. The -2 and -3 exactly the same thing. -3 -3 exactly the same thing. So you're gonna end up with the same asymptotes, right? But there's a difference between these two graphs. What is the difference? Yeah, that's right. It's a -1 right here. So what does this -1 do to the graph?
It's a reflection.
It's the reflection. That's right. It flips, right? It flips. It flips. So it becomes this way now. This one is L of x, whereas this one is K of x. And all because this -1. This -1 flipped it around, creates the reflection. Hey, are you ready for the next page? Because I want to go quick on the next page. I want to blow through number 8.
What if you don't do that?
No. We're gonna go to 9. Okay, go to problem 9. So look at the next page. Next page, I'm gonna ask you to skip number 8 and then do it at home and tell me what you're seeing. And you're gonna do all three graphs on the same plot. Okay, but I want to do number 9. I want to do number 9 with you. You ready to do number 9 together? All right, number 9. Here is where everything that we just learned will kind of help us. So number 9 says P of x is 2x over x plus 4. I'm going to close the door. Almost done there. Hang here with me. Now take a look at this one. I want you to stick with me. Analyze it with me, okay? You got a problem here, a function that sort of look at what we done before, but sort of not, right? If this would have been like 2 over x plus 4, you know exactly what to do, right? But it's not 2 over x plus 4, it's 2x over x plus 4. Kind of weird, right? And everything that led up to this point, all the graphs that you just plotted and the pattern that you saw seems to help, but also seem not to help. So let's take a look at how we can decipher this. Anybody have a clue on how to solve this quickly? How to basically have a mental picture of what this graph look like? A little hard, right? A little hard. All right, this is what you do. Take a look at this. If you have a function that is equal to some sort of function over some sort of function, this is what we call the rational function. Anything that's called rational is something that can be divided into something divided by something. So a rational number, 2 is a rational number because why? 2 can be written as 2 over 1. 0.5 is a rational number because 0.5 can be written as 1 over 2. So something over something is a rational number. Got it? So this is a rational function because this function can be written as something over something. Now, if something over something, it just means division, right? So now, hey, you remember this?
No. No.
Woohoo! Woohoo! Long division is coming back. Long division is coming back. So, okay, so I want to divide. I want to use 2, right? 2, yeah, 2. So this is 2 times x is 2x. 2 times 4 is positive 8. And this was 0 before. I can put a placeholder. And subtract, I end up with negative 8. Yeah? So can I rewrite p of x? Can I rewrite p of, so negative 8 is a remainder, right? But remainder, how that associated with the value 2 is that I can say it means 2x over x plus 4 is equal to 2 plus the remainder over what you divided with. Is that true? Okay, take a look at this. Do you see it? Do you see it? I'm so excited, right? Do you see it? P of x equal to x over x plus 4 can be look at it as negative x over x plus 4 plus 2. What does this 2 do to the graph? Move the horizontal asymptote up 2 units. What is this positive plus 4? Move to the left 4 units.
Okay. I love that.
Do you see it?
Oh my God.
Right? Moves. This moves the.
What if we don't want to remember Unit 3 because it was traumatic?
Horizontal asymptote up by 2 units.
In my head.
Right? And this one moves vertical asymptote to the left by 4 units. So I can easily now change this and sketch this graph out pretty quick. Now you say, what does this 8? Oh, by the way, and then what does this negative do? Flip it, right? It flips. And then what does this 8 do? It just becomes steeper. It goes a little faster. So the graph actually looks like this now. Very, very simple. Horizontal asymptote up to 1, 2. Vertical asymptote to the negative 4. 1, 2, 3, 4. Negative 4. Now, typically, the graph would have been this way, but because of this negative, it becomes this way. So your graph is this. Voila.
And the Oscar goes to you.
It's really easy, right? So you go from this. The trick is go from this to long division. Rewrite it in a form that you can recognize and take advantage of the pattern that you know about the reciprocal function. And then you have a graph. That's it for today.